Ever wondered how your new car gets from a factory in Japan or Germany to your local dealership? It travels on a ro-ro ship, a floating, multi-story car park the size of several football fields. These ships move millions of vehicles across oceans every year, keeping the global supply chain running. Imagine a ship carrying over 8,000 cars, stacked on a dozen decks inside a hull, like a skyscraper on its side. Buckle up, this is going to be quite a ride. So, what is a ro-ro ship? The name says it all. Roll on, roll off. Instead of cranes, vehicles drive straight on board via ramps. If it has wheels, it can board. A simple, efficient idea that revolutionized shipping. These ships are the backbone of the global vehicle trade, connecting factories to showrooms worldwide. Pure car and truck carriers, or PCTCs, are the most specialized ro-ros, floating garages optimized to pack in as many vehicles as possible. The concept isn't new. It evolved from train ferries and woolly landing craft, but after the war, ro-ros exploded in size and importance. Today's ro-ros are behemoths, bridging continents and slashing shipping times. A traditional cargo ship might take days to load. A ro-ro can turn around in hours. This speed is vital for the just-in-time economy where every minute counts. But this brilliant design hides serious compromises deep within its steel hull. Let's see what makes these giants tick and what makes them vulnerable. Let's talk engineering. From the outside, a ro-ro looks odd. Tall, flat-sided and blunt, maximizing space for vehicles. This shape is great for cargo, but acts like a giant sail in the wind, making the ship tricky to handle. Inside, you won't find small compartments, just vast, open vehicle decks called garage decks. Many decks are adjustable, raised or lowered by hydraulics to fit anything from city cars to construction equipment. This flexibility is ingenious, but it comes at a cost. Very few internal bulkheads. On a normal ship, watertight compartments contain flooding. On a ro-ro, water can sweep across the entire deck. That's a recipe for disaster if water gets in. Deep in the stern, massive engines power the ship and its systems. Ventilation is crucial to prevent explosive fumes from all those fuel-filled cars. Every part must work perfectly, or the consequences can be catastrophic. The ro-ro's open design is both its superpower and its Achilles heel. It's a marvel of efficiency, but one mistake can turn it into a death trap. Let's see how the loading process works and why it's so critical. Loading a ro-ro is organized chaos. A massive ramp drops and a team of expert drivers gets to work. They drive thousands of vehicles up the ramp, navigating a maze of decks and rows, parking each car with just inches to spare. Every spot is planned by the cargo officer to maximize space and maintain balance. Once parked, lashers secure each vehicle with heavy-duty straps or chains, crucial for safety in rough seas. Heavier vehicles go low and central, lighter ones up top. Get the balance wrong, and the ship can become unstable before it even leaves port. Every vehicle's weight and position is logged in a computer that constantly calculates the ship's stability. It's a relentless, high-stakes puzzle. One mistake, and the consequences can be dire. The speed and precision of this process are what make ro-ros so efficient. But the same open spaces that allow for quick loading also create deadly risks if water ever gets in. The next challenge, keeping these giants upright in the face of physics. Let's look at the science that makes or breaks a ro-ro's stability. Because when things go wrong, they go wrong fast. Why are ro-ros so unstable? It's all about center of gravity and the free surface effect. Their tall, open design means a higher center of gravity. Think double-decker bus versus sports car. The real danger is the free surface effect. Imagine carrying a tray of water, tilt it, and the water rushes to one side, making it even harder to balance. On a ro-ro, if water gets onto the vehicle deck, it sloshes across the vast open space, pulling the ship over with it. This can overwhelm the ship's ability to right itself. Capsizing can happen in minutes. Even a small leak, a damaged door, or firefighting water can trigger disaster. container ships have compartments to contain flooding. Ro-Ros do not. The free surface effect is the Achilles heel of the Ro-Ro design. Engineers have wrestled with this flaw for decades. When water gets in, the ship's stability can vanish almost instantly. It's a fundamental risk built into the very efficiency that makes Ro-Ros so valuable. And history has shown just how deadly this can be. The herald of free enterprise disaster in 1987 was a brutal wake-up call. A simple mistake. The bow doors were left open as the ship left port. Water flooded the vehicle deck. The free surface effect took over. In less than 2 minutes, the ship capsized. There was no time for lifeboats or warnings. 193 people lost their lives. The investigation revealed a culture of complacency. No warning lights on the bridge, no system to ensure doors were closed. The disaster exposed the terrifying vulnerability of the Ro-Ro design. It wasn't a storm or collision, just a failure of procedure. The tragedy forced the industry to confront its flaws. The lesson, even the most advanced ship can be undone by a simple oversight. The Herald's legacy is a stark reminder of the razor-thin line between efficiency and catastrophe. It changed the rules for Ro-Ro safety forever. But the dangers weren't over. The MS Estonia, sinking in 1994, confirmed the Ro-Ro's dangers, this time in open sea. A storm tore off the bow visor, exposing the car deck to the ocean. Water flooded in, the free surface effect took hold, and the ship listed violently. Within 30 to 40 minutes, the Estonia capsized and sank. Of 989 people on board, only 137 survived. One of the deadliest maritime disasters of the 20th century. The cause, structural failure, not human error. The bow visor, common on many Ro-Ros, was a fatal weak point. The disaster forced a global reckoning with Ro-Ro design flaws. The lessons from Estonia led to sweeping changes in ship safety regulations. Tragedy drove innovation, but at a terrible cost. After these disasters, the International Maritime Organization took action. Mandatory indicators now show if bow and stern doors are closed, no more deadly guesswork. Bow doors were strengthened or welded shut. New ships got tougher designs. Internal watertight doors and inflatable baffles were added to limit flooding and the free surface effect. Crew training and safety procedures became strict, with the International Safety Management Code enforcing accountability. Modern Ro-Ros have advanced stability computers, tracking every car's position and the ship's condition in real time. Alarms warn crews before danger escalates. Better weather forecasting and route planning help avoid disaster. The giants are safer, but the risk can never be fully eliminated. The lessons of the past are built into every voyage. So, are Ro-Ros floating death traps? Not quite. Their efficiency is also their vulnerability, but they're engineering marvels. Every day, thousands of Ro-Ro voyages are completed safely, thanks to stronger ships and better trained crews. The free surface effect remains a ghost in the machine, but strict rules and constant vigilance keep it at bay. The crews are unsung heroes, managing risk and reward on every crossing. The story of Ro-Ro ships is one of hard-won lessons and engineering trade-offs. Today's ships are safer, but never invincible. The industry has recalibrated, learning from tragedy. Next time you see a slab-sided giant on the horizon, remember, it's more than a ship. It's a testament to human ingenuity and caution. Ro-Ros keep the world moving, balancing efficiency and safety every mile of the way. And that's the fascinating, slightly terrifying truth behind these floating giants.